In this video we will discuss source free RC circuit. Okay, so we have a capacitor and resistor, and voltage across capacitor is V, and we would like to derive an expression for V. In capacitance C, this is R and this is I. So if you write KCL at upper node, sum of current leaving equal to 0. So first one is current passing through the capacitor, that will be C into dV by dt, plus another current is passing through resistor, so that will be V by R equal to 0. Now if you divide by C, dV by dt plus V by RC equal to 0. So this is the differential, first order linear differential equation we have obtained, and how we solved in source free RL circuit, same method we will follow here also. We will assume the solution. So assume V of t is equal to A into e power s1t, and substitute in this equation. So this equation 1, and we will substitute this in the equation 1. So d by dt of A into e power s1t plus A into e power s1t divided by RC equal to 0. And if you take this outside, A s1, if you differentiate, A will be outside, s1 is the constant, then e power s1t plus 1 by RC A into e power s1t equal to 0. So again here if you take A e power s1 t outside and 1 by RC equal to 0. To satisfy this equation, either A should be 0 or S1 should be minus infinity, but both if you consider these two conditions, then I of our assumed solution, that is V of t, will be 0. It's a trivial solution, so we'll consider the third option, that is S1 plus 1 by RC equal to 0. So S1 plus 1 by RC equal to 0. If you consider A 0, V of t will be 0, or S1 if you consider minus infinity, again V of t will be 0. So that we don't want here, 0 voltage. So it will be a trivial solution. So we will assume the third one, that is S1 plus 1 by RC equal to 0. So S1 is equal to minus 1 by RC. So this we will substitute in the assumed solution. So in assumed solution, what is the assumed solution? V of t equal to A into e power s1t, in that we will substitute this A into e power minus 1 by RC into t. We have to calculate this value A. So we know that already, and one assumption, see this not mentioned here. It is assumed that V of 0 is V naught. How we assumed in the source free RL circuit? Initial current of the inductor is I naught. So here initial voltage across the capacitor is V naught. It is charged to V naught. So that is the assumption. So then only we can see the voltage across the capacitor. If capacitor is not charged initially, if you simply take capacitor and resistor, you will not find any voltage there. So it is initially charged to V naught. So V of 0 is A into e power 0 equal to V naught. Then A is nothing but V naught. So our solution V of t is nothing but V naught e power minus 1 by RC into t. So this is the solution. How what is the response of voltage across capacitor? Voltage across the capacitor exponentially decays with the initial value V0 and it exponentially decays. And here time constant will be, here the tau will be RC. So if you substitute RC is nothing but a tau, then both numerator also time and denominator also will be time, unit will be time, so it's a time constant. Tau is nothing but RC. In the RL circuit, it was L by R, so here it is RC. So we'll solve one problem, and question is find V at 200 microsecond for the below circuit. Find this value, and circuit is and there is a switch here and it opens at t equal to 0. Okay, it was closed for a long period of time, but at t equal to 0 it is opened, and this resistance value is 2, this resistance value is 4, and V is voltage across capacitor, and the capacitance is 10 micron. Okay, so step 1, you have to first draw for t less than 0 what is the equivalent circuit. So t less than 0, switch is closed that time, at t equal to 0 it is opened. So what will be the circuit? Circuit will be 2 ohm and this is 4 ohm, and this capacitor, how we can model that one capacitor? I will write initial like this, capacitor, and this switch is closed, and this voltage I have not mentioned here, it is 9 volt, it is 9 volt, so this is 9 volt. So before t equal to 0, switch was closed for a long period of time, so already it has reached steady state. So that means capacitor, if you apply a DC voltage across a capacitor for a long period of time, and it can be modeled as a open circuit. So that we have discussed earlier. If a DC voltage is applied across a capacitor, it can be modeled as an open circuit. So this is a capacitor, or it can be modeled as an open circuit. No current is flowing through this one, and the capacitor will be charged to 9 volt because 9 volt is applied here. So capacitor will be having 9 volt, but no current is flowing through the capacitor. So at t less than 0, this is the circuit, and at t equal to 0 or 0 plus, we will, the moment when switch is opened, what is the circuit? So then we can write this will be as it is 4, and here this instead of capacitor, now how we can model? The capacitor resists the abrupt voltage change. So voltage across the capacitor at t equal to 0 minus, just before opening the switch, what was the voltage across capacitor? It is 9 volt. So that we can write here itself, V of 0 minus is 9 volt, because 9 volt battery is there across this capacitor, so it has to charge till 9 volt. But now at 0 plus, switch is opened, the voltage across the capacitor will not change instantaneously, so it can be modeled as a voltage source as 9 volt, and this is 4 and this is 2. But now at t greater than 0, now we will consider when switch is open, what happens to circuit? At the moment 0 plus, it acts like a voltage source, but when you increase the time, so if you keep it for long period of time, so again what is the circuit, equivalent circuit? It is 2 and 4, and this is the capacitor. You replace it by capacitor, and this is voltage V, and this capacitance value is 10 micro. Now we will write all the values. We have all this one. Step 1 is find the initial value. That is the step 1, initial value V of 0 minus. For that, switch should be closed. Calculate the voltage across the capacitor, that is V of 0 minus is 9, and you open the switch, and at t equal to 0 plus, what is the voltage across capacitor? So V of 0 minus is 9, and we know that V of 0 plus is nothing but V of 0 minus, because capacitor resists abrupt change in the voltage. So this will be 9. And second is time constant. Tau we have to calculate. Time constant is RC, and if in this circuit RC will be actually R equivalent into C, because we have two resistors, R equivalent into C. So R equivalent is what? 6. They are in series, 2 and 4 ohm, and C is 10 micro. So this is be 60 microsecond. So that is the tau. Step 3 is expression for V of t. So V of t, we know that it is V naught e power minus t by tau, or it is minus 1 by RC into t. So V naught we already know, it is 9 volt, and e power minus t by tau also we know, that is 60 microsecond. Fourth one is the value calculated. So question asked is V of 200 microsecond. This is the question asked. So you can simply substitute 9 e power minus, instead of t here you substitute 200 micro, divide by 60 micro. So this you calculate and write it. Okay. So this is how we solve a source free RC network.